LAI is basically the crop biophysical parameters, and that can be easily retrieved with the help of NDVI. We know that there is a relationship between the reflectance from the plants and the NDVI. If we closely scrutinize the behavior of the different bands, especially red band and the NIR band, these two are important as far as leaf area or the volume of leaf field that is concerned. We had learned in the theory that with increasing leaf area index, the reflectance in NIR will increase, because every single leaf is reflecting almost 50% of the incident radiation, and almost 50% is being transmitted to the second leaf. And when this 50% incident on the second leaf, so 50% of this 50% that would be reflected by the second leaf, and 50% of the 50% would be transmitted to the third leaf. The third leaf will get approximately 25% of the total amount of incident radiation at the top of the canopy. From this 25%, then again 50%, that means 12.5% would be reflected, and 12.5% would be then transmitted to the fourth leaf. So that way, with every increment in leaf area index, the reflectance in NIR band will keep on increasing. On the other hand, the red band is characterized by the strong absorption, and this absorption is mostly limited to one or two layers of the leaf. We had discussed in the past that first leaf will absorb almost 85 to 90% radiation in the red region that will incident on the leaf, and that means that only 10% radiation will left, and out of this 10%, 5% would be reflected and 5% would be then transmitted to the second leaf. And from this 5%, the 90% of the 5% would be then reflected by the second leaf, and again then 5% of this 5% that would be transmitted to the third leaf. That also means that with increment in leaf area index, the reflectance in red region will slightly decrease, but that decreasing pattern would be limited to only one or two layers of the leaf. Further increment will not affect reflectance in red region. Because of the contrasting nature of this NIR and red band over the plant canopy, these two bands are used to generate the index, and there is one popular index which we had also discussed last time, and we had created NDVI layer. In NDVI we used to use two bands, NIR band and red band. So the index equation is NIR minus R divided by NIR plus R. Today we will generate NDVI image, and thereafter we will develop a relationship between NDVI and LAI in order to retrieve LAI information over the larger region. As stated earlier, LAI is crop biophysical parameter, so you can also say that using NDVI value or using NDVI image, we can generate large area crop biophysical parameter like LAI. LAI is also directly linked with the crop biomass, so you can, on the basis of the same relationship, or maybe you can create a separate relationship, you can also generate information on the total biomass. So we will start today with generating the NDVI image, and then we will develop a relationship between NDVI and LAI. This relationship would be developed in Excel, and then the relationship in terms of the equation that would be fed into the NV software using band math calculation function of NV. Currently we are not having any measured value of leaf area index from the field. So what we will do is we will assume value of LAI of the selected field, and then the corresponding NDVI of the same field we will generate using NDVI image. So first we will open the software NV, and thereafter we will open the file. This time we will open the subset of the Pantnagar region which we had drawn from the LANDSAT images. The image is there in this LC08 subdirectory, and you can see this is the subset of the LANDSAT covering roughly entire Pantnagar region. So this image we are going to load, and you can see that this is the 5 band subset. Band number 1 is basically the aerosol band. Band number 2 is blue band. Number 3 green. 4th is red, and 5th is NIR band in this case. So as we had last time generated NDVI image, we will repeat the same process this time. So first we will display this region in FCC, and in FCC we will use combination of NIR in red, red in green, and green in blue. So this is FCC of the Pantnagar region, and now we will go to the band math function and we will write the same equation which will generate NDVI. Float B5 minus float B4 divided by float B5 plus float B4. Ensure that you have placed parentheses at the respective places in order to clearly define what is numerator and what is denominator. So we have separately placed these parentheses, a set of parentheses to represent the numerator and the separate set of parentheses to represent the denominator. Say OK, and now you will have to pair these bands. What is the meaning of B5 and B4? So B5 is here the band 5 which is NIR, and B4 is here the band 4 which is Z. So B4 would be paired with this band 4 and B5 would be paired with this band 5 which is NIR. Now we will write it on the hard drive like this. We can generate NDVI image, we can display, load band to new display, and this is NDVI. If you look at the statistics of this subset, you can see that the range would be limited to -1 to +1. The theoretical range of NDVI is -1 to +1. So all these values, values of the different pixels, you can see that is confined to that -1 to +1 range. Minimum value in this case is -0.011509, maximum is 0.530198, and mean of all the pixel is 0.20435. In this case the value of NDVI is not so high. The reason being is that when the image has been captured, at that time almost entire Pantnagar region was free from the vegetation because the crop would have been harvested at that time and the new crop would have not been sown. For that reason the mean value is still very low, it is 0.2043. Otherwise it could have easily gone more than 0.5 and the maximum value would have gone to 0.7, 0.8 depending upon the time of the season or the phenological stages of the crop. Now as I stated, we will develop a relationship between NDVI and leaf area index. So leaf area index should be measured in the field using any instrument like canopy analyzer you can use, or maybe septometer you can use, or there are certain other non-destructive techniques which can be utilized for measuring the LAI of the selected field. So assuming that you have measured LAI and you have also drawn the corresponding NDVI value, now we will tabulate all those values here in the Excel sheet. So first being the measuring point or field, you can write field. The second would be LAI, and third would be corresponding NDVI. So we will assume maybe 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and then the corresponding measured field value of LAI we will enter here, assuming the value as 1.1 and finally 4.24. These are the measured field LAIs that has been measured from the different fields. Now always remember that whenever you will go in the field and will measure LAI, at the same time you should also record the latitude and longitude information of the sampled point. So that means for all these 10 points you will have latitude and longitude, and then for every point, for every this LAI point from where you have measured LAI, you should then measure or you should then draw NDVI value. And how the NDVI value can be drawn? You see here, this is the image, and when you will press this cursor location, so you can see the latitude and longitude of the different regions. So you can just take cursor to that point from where you have measured the LAI. So that way you will get from here the corresponding NDVI value. NDVI value is this. So the NDVI value for all these 10 locations would be entered here. If suppose you are not able to navigate to that sampled location from here, then alternatively you can also use this pixel locator option. This is pixel locator option, and you can see right now it is in UTM projection and this value is in meter, so it would be a bit difficult for you to enter here the information. So what you can do is you can toggle this window, and when you will toggle it, then it will allow you to enter this information in degree, minute and second. You can also, if you have the value in that way, enter this value in degree and decimal. When you will press it, so then it will allow you to enter the value in degree and decimal. But in most of the cases you will get the information in degree, minute and second. So keep this degree, minute and second, and here you can enter the latitude and longitude of the sample point, and then it will take you to that sample point, and this red cross will directly fall on that pixel for which you have provided the latitude and longitude. So from then when it has reached at the desired location, then you can draw the NDVI value from this point. That way I am just entering here some assumed value, because we are not having these LAI value as measured value. So assumed value would be like this. It should be, LAI should be after NDVI. That's it. So first NDVI should be entered and then LAI. So NDVI should be, basically NDVI should be on x-axis, because on the basis of the NDVI you are going to predict the LAI, because for every region you are getting the value of NDVI and on the basis of NDVI you will generate the value of LAI. So for that reason, that the NDVI should be on x-axis, because in this case LAI is depending on NDVI. Okay, so LAI is dependent variable and NDVI is independent variable. So insert, scattered, and like that you can see. So now NDVI is on x-axis and LAI is on the y-axis. Now you can add trend line, and then you can also display equation with R square value. Now you can see that equation has been generated. If you want to mention these axes, you can mention. So accordingly you will have to choose. This is LAI and this is NDVI. So this is the relationship which you will use in NV software in bandmath function, and then on the basis of that equation you would be able to generate LAI for the entire Pantnagar region. So we will copy this relationship from here, copy, Control C, and then go to the image processing software, go to basic tools, again bandmath, and in bandmath you can just copy this. So once copied, then instead of x, you will have to define the band, and band you can define any number you can use, like b1, b2, b3 you can use, and then you have to pair it. So you should always pair this with this NDVI image. So we are going to write here float b1, and that's it. Say OK, and now it will ask you to pair this b1. So b1 here is NDVI image, so pair it with this, and then you can save it on the hard drive. Choose NDVI LAI, open, say open. Now you can see another image has been generated, load band, and now you can see this is LAI image. If you see these two images, this is NDVI image, these will appear almost same, the appearance is similar, but then there would be difference in the data. This you can see, this is representing the LAI, and the value of LAI would be more than 1. It is going up to maybe 4 or 5, but in this case it is NDVI and value will always be less than +1, because it may range from -1 to +1. So this is the difference you can see. And in the same manner you can also paint it in color mapping, NV color table, and now you can use green color ramp, green white linear, this, but at the moment white is showing the maximum value and green is showing the least value. So you can just reverse this pattern by pulling these stretch buttons, and now you can see the green colored regions are representing the higher LAI regions, higher LAI fields, and white color regions are representing the low value of LAI. But in this case, because you have run the equation on the entire image, so even those regions which are not having the vegetation, they are showing certain amount of leaf area index. For example, this is basically the built up land, and built up land is also showing some amount of leaf area index. You can see some amount, though it is very less, but it is showing. So what you can do is you can generate a mask of vegetative region with on pixels, and then that mask can be applied here, and then it will only show those pixels which are having the vegetation. Last time we had classified the image, so what I will do is I will display that classified image. Open. You can see, and you can see that these green pixels or the green color is representing here the biomass or the vegetation. So what we can do is we can generate a mask of the forest with on pixel, and then that mask can be applied here. So basic tool, masking, build mask, using this window number 4, say OK, and forest is having the value 1, you can see here 1. So the mask definition when we will give, always say selected area on, and then import data range from this window, say OK, and now say the minimum value is 1 and maximum value is 1, because we want to generate only the mask of vegetative region. Say OK, and now you can see this definition has been entered, and now you can save it as a mask on the hard drive. Choose mask, active, say apply. You can see immediately a band image with this feature that has been shown. You can display it in the new window. You can see that in this case the vegetative region has been represented with the white pixels, and all other regions have been represented by the black pixel. That means that these pixels are active pixels, and when you will apply this mask, so then the pixels of these regions with the original value of LAI would be shown, while all other pixels which will fall behind this, they will then have the 0 value. So go to basic tool, mask, apply mask, and the mask has to be applied on this image, right? We should select this. So this was the input file, no? NDVI LAI relationship. This should be selected. Select mask and this mask. Say OK. And say OK. Choose. Say OK. And now you can display broadband. Now you can see that all these pixels which were having the vegetation, you can see, can compare with these two. This is having the higher LAI value, and in this case these are having the vegetation. So when this active mask has been applied, so this is showing only the value of LAI of vegetative region. This is vegetative region, and the value of this region is being shown. You can see, and while this black region, because these were masked out, so these pixels are now having the 0 at that. Now it seems logical that those pixels which are not representing any vegetation, so those should have the 0 value of vegetation. You can also give color to it. Again, go to tool, color mapping, and the color table, green, white. Again, do the same process, and that's it. You can see now only the vegetative regions are showing the LAI value. So right.